Hello, fourth graders. It's Miss Ramos with you today, and we are on Module 6, Lesson 1. Module 6 is all about decimal fractions, okay? We are going to be talking about fractions that can be converted into decimal form, okay? Today's objective, we're going to be using metric measurement to model the decomposition of one whole into tenths. So the first type of fraction that we're going to convert to decimal form are our tenths, okay? Hopefully when you think about tenths right away, this pops into your mind, okay? If I have 1/10, it looks like that in terms of a fraction. We're going to see what that looks like in decimal form. This is the word decimal. Okay, so we're going to turn a fraction into a decimal today using tenths. All right, guys, so let's pretend we have 10 bags of candy. Okay, we went to Wegmans and we bought some candy. I have 10 bags, and my 10 bags all together are equal to 1 kilogram. Okay, so I'm just going to create my tape diagram here as a model of my 1 kilogram that is equal to 10 bags of candy. Okay. Nothing too new yet. Okay. So each bag would equal 1/10 of a kilogram. Okay, so each bag weighs 1/10 of a kilogram. Let's go ahead and model that on a number line as well. So we have a couple models to visualize this. So if I have my 0 and out here I have my whole, I can go ahead and line up everything with what I have above. All right, and here's my 5/10 and my 1 whole over here. Okay, let's take a look at what a tenth looks like in decimal form. Okay, and our decimal form kind of puts it in standard form. I'm going to have 0 ones, 0.1, which after the decimal, that's my place value called the tenths. Okay, so I have 1/10, and after that, I'm going to have 0 wholes, and then 2/10. Then I'll have 3/10. Then I have 4/10. And I have 5/10 or 0.5, which is also the same as 1/2, right? I think I've mentioned that a couple times. Now I have 6/10, 7/10, 8/10, and 9/10. Okay, so very similar to what we've been working on with tape diagrams and fractions. Now my number line is showing this same idea, but with those fractions in decimal form. Okay, so like I said, this place value after the decimal point is called the tenths place. Okay, and that relates back to our tenths in terms of fractions as well. Okay, so they just can be converted back and forth, and depending on how you want to use those numbers, you might have them in fraction form and you might have them in decimal form. Most of the time, decimal form is a little more user-friendly when you're talking about certain things. Writing fractions can be a little too much. You want to write it in a decimal form to be more efficient. Okay? All right, so there's our candies. If I have 1/10 of a bag of candy, I could write it as 0.1. All right, let's look at another example here. Now I have my ruler, and I see that my ruler is in centimeters, so I know that this is 1 whole centimeter. But I'm also noticing that I have my hash marks, and they seem to be marked out in tenths of a centimeter. Okay, so there's 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, if I were to draw myself a little picture here, let's say I had something I wanted to measure, a block or something. So my rectangle right now, it kind of looks like I have it lined up about here. Okay, so I can go ahead and measure, and I have 1, 2, 3, 4, 5. I could go right to my midpoint, 5, 6, 7, 8. So I could write this as 0.8 of a centimeter. Okay, but in decimal form, I'm going to write it as 0.8 centimeters. Okay, you can put the 0 in front to say that you don't have any whole centimeters, but the 0 out front isn't necessary. Okay, it doesn't change my number. Okay, I could have it there, I could not. So that's just a matter of preference for you. But mathematically, it does not need to be there. Okay, so I've got my 0.8 centimeters, and I've measured this rectangle. Okay, so we've been talking about converting our fractions to decimals, and this idea of unit form. We could think back to unit form. Okay, when I say my fraction and my decimal, I say 0.8, which is the same as the fraction 0.8, which is the same as the decimal 0.8. Okay, so they mean the same thing, they're just different ways of showing the same mathematical idea. Okay, I hope you enjoy your problem set and work hard on what you need to. Thank you so much. Bye-bye.